now we can start the session. So again I welcome you to the week 11 for the live sessions of the course Engineering Graphics and Design conducted by NPTEL. The course instructors are Professor Dr. Sunil Kale and Professor Dr. Naresh Datla from IIT Delhi. So again, introducing myself, I am Vikram Balaji, a research scholar from the Department of Mechanical Engineering at IIT Madras. So this is the 11th session. So I think this is, and I think there is one more session. So totally 12 sessions. So with this, we will be winding up our live sessions for this course with the next session. So let us go into the session for today. So before that, previous session, what did we learn? So in previous session we learnt about some few part modeling commands, especially any model related with sweep. Especially we saw what is a guided sweep, and then we saw how to create a solid and then convert it into a shell part, and then we also saw some example on how to create a spline curve, and based on the spline curve how to create a solid object. And then we also saw an example where we used the concept of revolve cut and generated objects, and so other part modeling commands we have been seeing in the last few sessions before that. And examples also we saw some 3 or 4 examples if I remember. So the part modeling session is almost done with that. So we are now going into the next module, which is called as the assembly module. Okay. So here you can see that Autodesk Inventor, as I mentioned in the some 3 to 4 sessions back. So there are some 3 to 4 modules inside the Inventor software. So one is the part modeling part modeling module. Second is the assembly module, and third is the drawing module. And another is there are some modules related to sheet metals, and there is another module called as animation. So now we are going to see assembly module of Autodesk Inventor. So an Autodesk Inventor assembly model is a collection of parts and sub-assemblies that function as a single unit. So the parts and sub-assemblies are connected by assembly relationships. So what we are doing is we are making many parts and sub-assemblies, and we are collecting and assembling them together so that they function as a single unit. The relationship control component placement and degrees of freedom. So we are defining what is called as relationship between different components. So that relationship we define that will control how the components are placed with each other, and how the degrees of freedom of the different components are going to occur. So in essence, there are actually 2 methods to create an assembly in Inventor. So one method is we can insert the components into an assembly. So if you have already done some components in the part module, we can insert them after the part modules are created, and we can assemble them together. That is called as the bottom up strategy. The second strategy is to go inside the assembly module and create the part then and there, and assemble together. So that is called as top down approach. So in this session we will follow the bottom up approach. That is, if you are given some assembly drawings, we will first create the parts in the part module, and then we will later open the assembly module and then assemble insert the parts and then assemble them together. So we have to use something called as commands to define the relationships, position, and degree of freedom. So there are many commands in the module assembly module. So we will see that in this session. So using the example, so using that commands, we are going to define the relationships between the different components. Those relationships, as mentioned here, they control the placement of the component and the how the degree of freedom are constrained. So we will now go in further. So we will see an assembly example for today's session. So here you can see we have an assembly. You can see that this assembly is composed of many parts. So you can see part 1, part 2, part 3, part 4 and part 5. So So this assembly is called as a linear slide assembly. So here this is called as if you see here, there is a sheet 1 is there. So this linear assembly slide assembly is shown in the sheet 1, and the assembly is shown in a exploded view in sheet 2. So if you go to next page, so here you can see that the different component assembly is exploded, and the different components how they are assembled is shown. So as seen here, the assembly is composed of parts 1 to 5 shown in the subsequent figures. So here you can see that there is part 1, part 2, part 3, part 4, part 5, as I already mentioned. So they are and these parts are shown in the subsequent figures. So here you can see part 1 diagram is there, part 2 is there, here part 3 and part 4 is there, here part 5 is there. So we are given the today's session, we will be doing this following task. So first we will create the part models of parts 1 to 5 using the standard template of the part module. Then we will assemble the parts together using the standard template. So this is the new assembly module, and further we will also generate some orthographic views and some sectional view of the assembly using the drawing module. So today we are actually in essence covering 3 different modules. The part module we already covering in the last 3 to 4 sessions. Then now we are going to see the assembly module, and then we are going to see the drawing module as well. So let us start. So here part 1, the exploded view is shown. So here you can say that the part 1 is called as a base. So there are some holes provided on this part, and there is some rail. So this is looks like a rail system. So the rail is can say is a part 2. So that part 2, the holes are provided. These holes are going to sit exactly on the holes which are provided in the part 1. Then after, there are 2 rails in this system. So after these rails are fitted on the base, so upon the rails we have something called as sleeve. So these are the sleeve. So there are four sleeves are there, 4 part 3. So these sleeves are going to sit on this rail. So after the sleeves are fitted, we can say that this slider, these are the part 4 is called as the slider. So the slider is going to sit on this rail, and we can say that after this part 4 is fixed, upon that we are going to place this another slide. So this is part 5. So here on this slider there are some holes provided, and on this top also there are some holes provided. So these holes, after these 4 parts are placed together, so it will exactly, they will match. So you can see here, so this is part 1, the part 2, the rails are sitting exactly on the holes provided on the part 1, and part 3 you can see that there is a slider over here, sleeve, sorry. So if I shade this one, so this will be the sleeve actually. So once this sleeve is seated, so we are going to place this slider on that, and this is going to be another base. So this is part 1. So we can, if you want to give the names, you can give. Yes. Okay. So I'll call it as base. So why I am naming is that because once we name, we have to save these parts in this name, and later we can see that when we are having assembled and did the drawing, so finally when you are generating the bill of materials, so instead of part 1, part 2, part 3, we can have the names also. So part 2 I am going to name as rail. Part 3 I am going to name as sleeve. Part 4 is slider. So part 5 we can say is top. Okay. So now we have seen the drawing. So one by one we will do the part modeling. So this is part 1. So part 1, as I told, it's a base. So here we are given a rectangle, and it's like a cuboid system. So upon this cuboid there are some holes which are there. So now we can start to model this part 1. So I will go to this one. Probably I'll go to Autodesk Inventor. So I'm going to open a new part this thing. So we are going to do bottom up, which means that first we are going to do all the parts in the part command, and then finally we'll open the assembly and do the assembly. So we are going to go for standard for part. Give the create. Okay, so it is loading, I think. So we have got them. So let us now go back to that. So now we are just going to create a rectangle and first extrude it. So this dimension you can see here is a 100 by 60. So let us start the sketch. I'm going to sketch in this plane. So first I make this rotated. So now the top is clear. So 160. So I create a rectangle. It's a center point. So I select the origin. I give 100. Then 60. Click enter. So I get it's a constraint. So now I can finish the sketch. Can do the zoom all. Now I'm going to extrude this. So to what height I have to extrude? It's given here by 4 mm. So I select 4 mm towards the upward direction. So I click the OK. So I got this thing. So now I have to create the holes. So how many holes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 holes are there. So first I will start to create this hole, then we can use the pattern to create the subsequent holes. So now I click the hole. I click the surface. So before going into the hole, I'll place the hole first. So I am going to select this center point and this thing. So what should be the distance? This distance should be 10 and it should be 7.5. So this is 10 and from this point to this point that should be 7.5. So now I will select the through all hole. So it is go up to the depth. So the whole dia is 2 mm. So 2 mm is already given. So I click OK. So if I go to top and see, so you can see that one hole is generated. So next I have to copy this hole by 40 mm. So if you see that this placement is exactly to the center. So this center point from this side 10 mm, from this side 7.5. So that's how we have placed it. Same hole I am going to 40 mm. I am going to create this thing such that this is 40 mm, and I am going to create 2 more instances. So this is also 40, and in this distance I am going to create an offset of 10 mm. So which means that with this one hole I am going to make a pattern so that I get the 6 holes. So I'll click this pattern, rectangular pattern. So feature, I click this hole. Direction 1 is first direction. So I flip the direction and I place the spacing as 40, and the number of instances I give as 3. So you can see that 1, 2, 3 are there. So second direction I will again select, and in this I have to create 2, which means 1 and 1 below, and spacing is 10 mm. So if I click OK, I am going to get all the 6 holes. So now this entire pattern, if you see 1, 2, 3, 4, 5, 6. So if I select this all the 6 as a entire pattern, so from this point to this point, you can say that the distance is 25 plus 10, 35. So 35 mm from this point to this point if I am coming means, also this circle also will come to this circle, this circle also comes here, similarly the bottom also comes here, because if you see the total, so this will also, if you count and see, this will be 10 mm. So if you see here, this is 7.5, this is 10, so this is 25, this is 7.5, so 15, 20, 25, 50, then remaining this will be 10. So same pattern I am going to offset at 35. So again I am going to create this pattern. So features, I am going to select this rectangular pattern directly. So I can select, if I select any of these holes, so all the 6 are selected, so only along one direction. So going to this direction, so spacing I am going to give 35. So if you see here in the preview, the same 6 holes are being repeated over here. So if I click OK, now I got all the holes. If in the first itself we could have not done, because this distance is differing, but once we created the 6 holes, then we can easily offset this. So now all the holes we created, so this part 1 is done. So let me save. So I'm going to save in the week NPTEL week 11. So first I'm going to save this as base. Okay, so this is saved. Again go to home. Now I'm going to create a new part. So now we are going to do the second part. So if you go here, now we are going to dimension, create the rail part. So here what we are going to do, we are going to make this profile, and we are going to extrude this profile along 100 mm. So first we'll look at this profile. So here we have some 15 mm base is there, then we have 2 mm of this thing, then we have some vertical stem, and we have a round profile. So this we are going to create now. So first let us create a rectangle of 15 mm and 2 mm. So sketch. So this I am going to do in so let me see. So this was, so if this is our front view, so this will be our left side view. So if this is front, I am going to create in, so let us say that this is our front. Yes, so this left side view I am going to create. So which is this plane. Yes, so left I am creating. So now I am going to create this profile. First I create the rectangle. So randomly I am creating. So next dimension. So this will be 15. This will be 2. Now I am going to apply the symmetry. Let me say this is the symmetry. So I am going to select this edge and this edge, and I am going to make symmetry about the y axis. So now these are symmetry. So again this dimension with this point I am going to go inside, make it 0. So once I did that, I constrain this. So we got the rectangle now, and now we are going to create another some 2 random lines which are at 2 mm distance. First I will create the circle, then we will trim it later. So from this base I have to create a 8 mm height. So from this point I'm going to create a circle which is at on this, and what was the diameter of the circle? Radius 2.5, so dia 5. So dia 5. So if I now select dimension, the center point and this top point at a distance of 8. So the circle is also constrained 8. So now I am going to create these two lines. So now I am randomly going to create this line in a vertical fashion. So once this line is created, so now I have to, this is 2 mm, so this will be 1 mm from this. Okay, so this is also now fine. So I am going to just mirror, going to create a mirror. So this is my line, so mirror line, y axis. Okay, let us not mirror, so it's not working. So I'll again create that line for, and I'll do that thing. Vertical line I'm creating. So dimension, yes. So now I'm going to just trim the extra things. So this line, this one, and this one. Yeah, so now this one. So once we trim, we see that again some it's not constrained, so we'll try to again do that. So this 8 is there. Okay, this extra is coming. Be vertical, have to or horizontal. Okay, so this line is done. This is also now it is fully constrained. Okay, so we will finish this sketch. Now we are going to extrude to 100. Select the extrude, select the profile. This is the profile. So I'm going to extrude in both the directions equally 100. I'm going to extrude. So now I got this solid. So now I have to give some fillet. So here R2 and here also R2. So I will select this fillet command. I'll give the 2 mm already selected. This edge, then similarly this side and this side. So finally I give OK. So you get the filleted object. So now we have did this profile and extruded and fillet. Now we have to insert the holes. So this hole, if you see, so this is 2.75 and this is 10, and this total is 15, we can say. So okay, so 2.75, let us not, we will keep it as 2.5. So because if you see 10 plus 2.5, 12.5, if it, then this will also be 2.5. So then only it is looking asymmetric, otherwise these holes will be unsymmetric. So this also 2.5. So let us keep it as 2.5. So this we can slightly change it. So first from this edge 10 mm, from this top edge 2.5 mm. So that's how I'm going to create this hole. So let us view from the top. I'm creating a hole on the surface. So this distance to this distance 2.5, and again here to this thing 10, and this is 2 mm is there, and it is through all. So let's select OK. So we got this hole. So again, now what I'm going to do, I'm going to create the pattern. So same 40 mm 3 instances, 40, so 3 instances. So this is 10 mm 2 instances. So pattern, select this. So direction 1, this one. So spacing is 40, and I'm going to 3 instances, and here I'm going to select this, switch the direction, and 10 mm. Is it 10? Yeah, it's 10 mm spacing. So center to center. So dia 2 holes, so we have done. So let us give the OK. So now we got the this thing also. Okay. So now we will save this as rail. Okay. So now again go to the home, create the new, again part, next part. So we have first this sleeve we will create, and then we have to clear this slider. So now let's create the sleeve. So sleeve also, if you see, it is located in the left side view only. So front view, so this is left side view. So here if you see, this is a third angle projection. If you see, because left side view comes towards the left hand side. So again we'll set the sketch to the left side. So which is this sketch. Yes. Now I'm going to create 2 concentric circles. Half radius 3.75 into 2 means, so dia 7.5. Is it 7.5? Yes. Dia. So this into 2, dia 5. So dia 5 and dia 7.5, 2 circles I am going to create. Circle 7.5. Again one more circle 5. So now we created the 2 circles. Now let us create one line from this to here. Okay. So now I'm going to dimension the angle. So this okay, or let me do one thing, I will create one more line. So now I'm going to create a dimension between these two. So I'm going to create a 120 degree. So this is not symmetric, so again I will apply the symmetry command. So I select the first line, second line, symmetry about y axis. So now it is automatically constrained. So extra part I have to trim now. I trim this part, this one, and this one, and inside also I have got to trim. Yes, so yes, somebody has raised a hand. So any doubt? Silvaraju sir. So any doubt is there? So I think raised a hand. Okay, maybe by mistake. So again now you have to see this. So it is because of the trim it has become unconstrained. Anyway, you can leave it as such, no need to, but we will again try to constrain, not a big issue. Symmetry as okay, so that constraint already exists, so I have to maybe dimension maybe I'll add a construction line in the y-axis. This construction. So now you can dimension this line. This line. $60. Yes, okay, already 60 is there, so 120 again symmetry. Okay, so maybe I have to create this dimension. Okay, so it is constraining when I give this. Okay, so now let us finish. So now I'm going to extrude it. So length of 20 mm. Select this profile. So two times, like symmetrically I'm going to 20. So select OK. So now we have created the sleeve also. Okay. So this part 3 is done. So now slider part 4. So first what we will do, we will create this square. So this rectangle. So this is dimension 15, and if I slightly move this, so you can see here it is 10 mm. So 15 by 10 I am going to create a rectangle. I am going to extrude it for 20. So let us do that. So again, which view we have to check, because while assembling it will be easier, convenient for us, otherwise we need to rotate it and those things and all. So this also in the left side view. So again in the new, I open, okay, create a new sketch. So this time also I am going to create it in the left side view. So this is left to me, so I select this. This is the thing. So first I want to select a rectangle. First the dimension 15 by 10. Okay. So now finish this. Going to extrude it up to 20. So same length as the sleeve, you can say. Both sides 20. Okay. So now again I start the sketch. I sketched in this plane. So now again I draw a rectangle. So randomly first I draw. So dimension 2 mm height, 25 mm width, 25, 2. So this anyway symmetry I am going to apply with respect to y-axis. and now this dimension I'm going to, from this point I'm going to make it coincide. So now this is also finished. Exit the sketch. Now I'm going to extrude it for 20 mm. This is the profile. So I'm going to give a unidirectional for 20 mm, or I can select up to this surface also. I can select. If I select to next, it's not to here, then automatically that also it is taking 20 mm. So let me give OK for this. So now I have to create this circular cut. So for that I am going to create a sketch in this plane. So my circle center is located somewhere here. So let me draw the circle first. So maybe somewhere here. What was the circle size? Radius 3.75 means again 7.5 dia, which will be equal to the outer dia of this sleeve, because this is going to sit upon this, so it is quite obvious. And now dimensioning this and this edge, it is a 2, which is 2 mm, and now I have to make this coincide. Okay. But 2 mm I have already given. Okay, 7.5 center. Fine. So now I finish this. I am going to do the cut extrude. Select this profile. So now instead of this thing, I am going to give the cut. So automatically it detects the direction. So I am going to go up to next. So which means automatically 20 mm it detected. I click OK. So now I got this thing. So now I'm going to create 4 holes. So first hole I am creating, which is 15 mm, 20 mm means, so these two will be equal. So it will be 20 minus 15, 5 mm, 5 mm by 2 will be 2.5. And this same thing again, this will also be 2.5 because it's a square. 20 not it will be 2.5 but not square. So 25 minus 25, 5 by 2, 2.5. So 2.5, 2.5. I'm going to create a hole here. It's also 2.5. 2 mm hole, is it? Yeah, it's 2 mm hole. And 2 r. Let me say up to this. Oh, okay. So we created the hole. But what was the hole size? It was 2 mm only, right? Yeah. The drill point, it is flat. now I'm going to go make a pattern, which means that here 15 mm like this and 20 mm like this. This direction 15, second direction 20, flip 1 2 3 4 holes are done. Anything else, I think it's done. So part 4 is also done, so we'll save it as slider. Again go to home. We'll now create the last part. Same thing. Okay, so now we are going to just create a plate, 60 square plate, and then we are going to drill 16 holes. Square plate. This is going to be on the base plane. 60 by 60 square. Finish sketch. So I'm going to extrude it up to 6 above. Okay. So now again hole. First hole I'm creating this. So 2.5, below also if you see 15 25 15, which means 25 14 55. Same thing will be each this will be 2.5. So each hole 2 mm, so 2.5. This 2.5. Again I click the whole center, this edge, this also 2.5. So the this 2 mm, so 2 to this surface. I do the hole and I click OK. So now what I'm going to do, I'm going to create this pattern. So this is 20. So I'm going to just copy this hole by 20 mm. What I'm going to do or else I can do 20 mm 15 mm. So I can create this unit. Go to eraser. So from one hole I can generate 4 holes. Pattern, select this hole. So direction 1 along this side, 20 spacing, and direction 2 top 15. Flip the direction. Is it so? Yes, 15 20. I give OK. So 4 holes I have now got. The same thing, this is 20 plus 15 35. So 35 mm I am going to make this pattern. So select pattern. So select any of these. So all 4 are selected. Direction 1. I am going to just create a 35. So you can see again 4 holes are copied. So now 8 holes are generated. Again this I am going to pattern it from this 15 plus 25 above. So from here this hole to this hole corresponding we have to look. So it is 40. So again pattern, select this. All 4 are selected along one direction. Switch the direction 40. So we can see that now all all 16 holes are now drilled. So let us now look from the top. This is how this thing looks. Home view. So this is the top. So now all 5 parts we have created. We'll save this and make it as top. Okay. So now all parts we have created. So now we have to go to home, and now you have to click the new. Now we are going to go for the assembly. So in assembly I am going to already it will be in the PowerPoint, I think. So standard mm we are going to go. Standard mm I select to create. So I'm going to place the parts one by one now. So first we will place the base. So here the place command is there. We create the place. So week 11. So base I am going to place. Yes. So I placed one. So one base is now placed. So I will going to right click this. I am going to select the grounded. So if I selected grounded means, if I go for this and check the degree of freedom analysis, so there is zero translation, zero rotation. It means this object is now fixed. So once this object is fixed, it will be easy for us to now place the other objects. So next is we have to place the rail. So rail we are going to place. So why I did, now you can see that why I chose left side view means now it is directly in the alignment. So now we don't need to do any rotation, those kind of stuff. So now I place this and I place 2. So both I have to now. Okay. So first I will place this and then I will place this. So now what I am going to do, I am going to mate 2 of the surfaces. So which means that this bottom of this rail and top of this base I am going to mate it. So you go to constraint, select this first option mate, and again here mate, and we have to select the bottom, slightly rotate, select this top. So now it has now placed. Now it has now placed it. Second, now what I have to do, I have to I'll click apply. So that has been done. So next I am going to do flush command. I am going to this surface and this surface I am going to coincide, which is flush means both will be along the same this thing, share the same edge. So I click the apply. So additionally I am going to, so if I come back now, I will be able to still move this. So like this, like this, like this. Other direction I won't be able to move. So if you check the degree of freedom analysis, so one translation is there for this first rail. Second rail we have not yet done any operation. So if you see, this is the one translation along the Z direction. So now we are going to fix that one also. How we are going to do, let us see. What I am going to do, I am going to this hole and this hole I am going to mate. So sorry, not joint. So constraint. So mate option. If I select the whole edge, so you can see that axis is now activated. I select that one. Second one, this one. So now it came and sat. I click the apply. Now top view, if you see, exactly it is now this thing. So let me give a different color to differentiate it from the base. Let me give the gold color. So just like this. So again same operations I have to do now. So I'm going to mate two surfaces. This bottom, top. So now I click apply, then flush both of these. Again mate I am using. Okay, why I am not selecting, able to select this whole. Maybe selecting multiple. Constraint. Oh, sorry. First one. This is and we use it on this. Apply. Okay. So again, this I select and give the gold appearance. Glossy gold. This also glossy gold I will change. So now to two rails I have now. So now I am going to insert the sleeve. So if I again check the DOF analysis, all are now constrained. Place the sleeve. Okay. So sleeve I am going to place. So before going, we have to just check where exactly we are going to place the sleeve. So if you see, if you determine the position of the slider from this edge, so it means that you have determined the position of the sleeve also. So this edge you have to determine what is the distance. To do that, so first how we are assembling this we need to see. So finally when you are going to see, this plate is going to sit on this hole. If you look that way, you can get try to do that. So if you see part 5, so this is 60 mm. So upon this part 1, if you are going to do that, so this is 100. So from this we have going to place a plate upon this 60 by 60 we are going to place it. So let me take another color. (60 by 60), which means so somewhere like this. Oh, so this is also 60. Okay, so here is this. So it will come to full length. So somewhere like this it's going to sit exactly in the center. So that is going to have 16 holes. So here some holes will be there. So this hole, if you see this distance from the center for the part 5, so this you can see that 60 means, so this edge if you see, so this will be 30, sorry, so half the distance, so this will be 30 from this. And if you see the arrangement, this edge also coincides perfectly. So So these two edges also coincide perfectly. So this is 30. So what is the distance? This the remaining distance is, you can say it is 20 mm. So yes, so this will be 20. So which means that if I go to this exploded this assembly, so this distance is going to be 20 mm. So now I know where to place this sleeve. So let us now place, first of all we will do the constraining. So we shall first made this axis and this axis. So now they are exactly placed. So now I am going to do the aligned. So now I am going to do mating, flush. First I am going to flush it, these two. Offset I am going to give 20. So it from this flush surface it gave the offset of 20. Now I click the OK. So still if you see degree of freedom, one rotation is left, so it could rotate along. So how we are going to constrain that? We see here this is 120, so which means that this will be 60. So we are going to give the angle constraint. So we will see how we give that. So from where to where we have to give the angle, we have to set. Yes. Now we have to select this angle, this one. Okay. Now 0, we give 60, it's coming this way. So if I give 120, so now you can see that this 120 is, if you satisfy, it is now sitting perfectly. So 120 degree, I click the apply. So if I now check the DOF analysis, it is now fully constrained. So again I have to insert 3 more sleeves now. So one sleeve, one by one we will do. Constraint, axis, this is now okay. So now flush, apply. So now again I have to do the rotation. This is the second angle. This angle, directed angle, we have to select. This edge, 120. Yes, do the apply. Again degree of analysis, all are okay. So similarly I have to do 2 more sleeve, open, okay, constraint, axis, okay. So now I am going to this direction. Give the flush. So if I first give flush, actually it is coinciding. Other, now I have to give offset of 20, then it will go back. So that we apply. Then finally angle. I select this direct from this and this one. So it is 120. Is it 120? Oh, I think I made mistake. So again I'll go to sleeve 3. Okay, this is, I think I'll delete this. Okay, now I select on 120. Okay, not 120. Okay, minus 120 it's coming. Yes, I give the apply. So now that is also constrained. So one more now. Place, sorry, sleeve, constraint. First made the axis. Okay, apply. From here I give the flush and offset of 20, that also I apply. Now angle, this one, minus 120. Now it is seated properly. Give OK. So now all 4 sleeves you will select. We'll give some new color to differentiate from the other parts. Let us say we are giving the red. Okay, so now sleeves are done. Similarly, now I have to do the slider. So 4 sliders we get. Again now I have to do the constraints. This axis and top axis, so that apply, then flush this surface, apply, and angle I have to give because it's still the rotation is there. I give 90 or minus 90. Yes. So this is now constraint. If you see DOF, slider 2 0 0 is there. This is slider 2. So slider 1 now I will do. So axis, fall this way. Flush, then angle. So this perpendicular, so these 2 angles 90. Yes, same thing I have to do on 2 more times. Apply. So now again flush, and angle. Okay. So this is fine. So again we see degree of freedom analysis. Now one more last slider we have to constrain. So we quickly constrain that. So we select the inner surface, this axis gets selected. Then I select the top of the sleeve, so that is applied. So I now click apply, and I have to do flush between this surface and this surface of sleeve, so that also I apply. And angle, so maybe one edge and this vertical edge, select this. So now minus 90, or I should be plus 90. Okay. So all now slider is also applied. Final one more component we have to place is this top. So this we are going to place only one. So you should see how we are going to place it. So first of all, we are going to make two surfaces. So bottom I select, and this top one I select. So automatically it is now seated. Mating is done. Next thing, have to flush two surfaces. So I click apply, then I click this surface, apply the flush, and then again one more flush, this surface and this surface, click apply. So let us see from the top. Okay, why the holes are not visible? Oh, okay, this fine. I think it's visible, right? So let us see. This will change the color. I'll make some orange. Okay, here through this it is seen. Yes, now we can able to see through, but this surface we cannot see through. Fine. So we have now assembled. So we'll save this one assembly 1 we will save, or we'll say slider assembly. I think slightly change settings. Default speakers is there, microphone, okay, internal. Okay, so we have saved this assembly. So now we will go to this one. Finally, one more last, we have to just create the drawings. So now to create the drawings, you can see that here, if you see, you have to create the template in ANSI mm. So this one will create that. So here we see that the drawing sheet has been generated. So now we click the base. So select the document, slider assembly. So we see one base front view has already been generated. So let us increase the scale, probably 3:1. So you can see that the front view is there. So if you see the slider, so if you go here, so this is a slider means, so exactly as this will be our front view, this will be the left side view. Okay, so we will keep this one front view slightly below. Top view we will keep on the top. So we will select the projector, click this. If I click here, I right click, create. So I have got the top view now. So these rails, you can see top view I have created. This again I will slightly bring down. So from here I am going to create a section view. I will select this front view first, then I am going to select a line which passes entirely like along the middle. So if I keep the right side or left side, so if I keep to the left side, automatically the arrow is pointing towards this thing. If I go here, automatically the arrow is also shifting. So let me keep in the right side, left side view. Left side view will be our section. So we see the section. So if we split the section, so which means that exactly a plane passing through this center. So we have created a section view. So this we can slightly pull and we can see. So we have created a orthographic with one section view. This also is done. In assembly view, we usually do not do the dimensioning. We do the dimensioning in the part views. So we will not do dimension. And finally, in the annotate, if you go, so we can do the parts list. So select document, slider assembly. So if I go and maybe in the top I can keep. So if you see here, so all the 5 items are there. So one base is there, 2 rails are there, 4 sleeves, 4 sliders and 1 top. So finally we have created all the views. So this again I will pull slightly below. If you want to, maybe you can do the leader lines, we can do, you can insert the part or something. So this part list is there. You can create balloons. So if you want to do this means, this is part 1 like that. So this is part 5. It is automatically showing top 1. You can see here that balloon is showing top 5. Similarly, if you create another balloon for this means, so it is showing part 1. Okay. So this is part 1. So similarly, this if I do, this is part 4. This is the slider. This part 4. And part 3 I will be able to do here. For example. So this is part 3. So this rail will be part 2. This I can do here also. Okay. So finally we created the balloon list, part list also, and we have created the part list. So again I will save this slider assembly drawing. Okay. Okay. So we have finished this session for today. So we will just quickly go through and we'll see. So we saw first what is assembly module. So we saw this assembly example. So we first one by one we created the part models, and finally we assembled and created this assembly. So this is the slider assembly, and this is your slider assembly drawing. So you can see here. So here is it, slider assembly is given. So here parts lists are given. So we have finished one assembly for this. So with this we conclude our session. So if there are any doubts, you can please ask. I think my this thing is disabled because earphone some warning has come, so maybe I won't be able to hear you. So if you have any doubts, you can please message in the this thing. So if you don't have any doubts, you can also message saying no doubts. So if there are any no doubts, I will stop the presentation. Okay, so no doubts, fine. So I will go to here, I will first